Hello, class. This is your Math 0410-0105 instructor for Elementary Algebra Plus. I'm going to do a recording or a Zoom recording, which will turn into a YouTube video at some point. But for your upcoming quiz number 2, which covers sections 2.1 and 2.5. And so let me just go ahead and transfer this over to share screens. And screen. Go. So what you can see here is that I printed the template from your Math 105 course that holds the template, and it's in the module related to quiz number 2. So there's a module, look at the headings, it's related to quiz 2 in your Math 105 Canvas course. And this is kind of what the template looks like. Now, I know it says 40 minutes there, but I'm allowing for 60 minutes. So let's change that to 60 minutes. But it has 9 problems, and we'll go through this. So I'm using version B from your course workbook. So on page 42, there's 2 quizzes, 2 practice quizzes for these sections, and I chose version B. So that's usually what I'll plan to do when I do a demo. If there's 2 of them, I'll use the second one. And so you can see the first question here is noted. Also, if you do version A, the first one, or version B, or there's also one online, and you upload your work for that, then you will get 5 points added to your quiz score. You can also use the guide to jog your memory while you're taking the quiz. Okay. All right. Okay. So I'm going to let's see. I'm going to just stop the video so you can concentrate on work here and see. And your larger calculator, your little scientific calculators. Okay. So first it says, raise the following fraction to higher terms as indicated. 9/22 equals question mark over 110. Show your work. So not just the answers what you put in the computer, but on your paper, your teacher needs to show some work. So what we can do is you want to find out, because you want to make equivalent fractions. So you want to ask yourself 22 times what equals 110. So I'm going to just write that down here. So 22 times what number equals 110 question mark. So we can start with making some multiples, like a multiplication chart. 22 times 1 is 22. 22 times 2 is 44. 22 times 3, because 3 times 2 is 6, 66. 22 times 4. So 4 times 2 is 8. And of course, you can always double check, on your calculator doing that. 22 times 4, 88. 22 times 5. 22 times 5, that might be the one that works, is 110. See that? So that means that we need 5 multiples of 22 to arrive at 110. And so we're going to build up this fraction. Okay, and so we want to multiply the bottom and top of that fraction. So the bottom is the denominator, the top is the numerator, but you want to multiply the numerator and the denominator of the fraction 9/22 by 5. And because it was 22 times 5, that gave us 110. So I'm going to show this. So on your test, you don't have to write all these sentences, but you do need to show me that you're multiplying times 5 times 5. And then to know how did you get to 5, make a little list of multiples there. That doesn't take very long. It takes less than a minute or two. I am giving you, after all, 60 minutes to work on the quiz. So your teacher does expect some work on your paper for that. And then when you double check 22 times 5, that should check that. That does give you 110. And then 9 times 5 is 45. So this would be 45. Okay. And then your answers are also in your workbooks. Let me take a look at that. Let's see. Let me pull up the workbook here. That's what page they were on. So it looks like on page 52, we have some answers, and we're doing practice quiz version B. Version A doesn't have version A attached to it. It just says practice quiz number 2, answer key. But the second one, the version B, has version B attached to it. But you can see there on number 1, see that right there. It says 45 over 110. So I'm just going to, check my work. Sure. So in the computer, you would probably have to put in this question mark in the computer. You would have to fill that in probably on the computer, the 45. And you'll know when you do your homework because it's similar to your homework. Okay. And that would be the way to show your work for that. I think showing your work on how to get the 5, this would work, or you could show. Here's another idea that I would allow you taking the 110, because in math we undo multiplication with division. So another way we can do this is divide. We could take 110, show 110 divided by 22, or show it like this, 110 divided by 22. That would be another way to show that. So if I do 110 divided by 22, see how that gives you 5? That would give you 5 right here. And I have a multiplication chart. I think I have, because you are allowed to use some handouts. So you would be allowed to use your multiplication chart in your workbook. This is Roman numeral 6, right? Roman numeral page 6, Roman numeral. You've got a little multiplication chart that only goes up to a 12 by 12, but on Roman numeral page 7 here, you have a bigger multiplication chart. So if you wanted to see how many times does 22 go into 110, you see this goes 30 by 30, right? 30 by 30. So you can see here 22 times 1, 22 times 2, 22 times 3, 22 times 4, 22 times 5. See that right there? So oftentimes the multiplication chart is helpful to use your rulers. So you could see that here also, right? 22 times, and then so if you have 2 rulers, it's helpful. 22 times 5 times 5 is 110. Yeah. So that kind of might be helpful as well, using that as a tool. But this is another way to show your work. So either do your multiples. This is called like a list of multiples, or you can show some division. Okay, either way. And then, of course, you need to show this work. Okay, all right, and that'd be sufficient. All right, what you can't do is just, don't just put the answer 45 and no work, to put some work on paper. Okay, problem number 2, reduce the fraction to simplest form, and then see, reveal the common divisor that's used. Okay, so these are even numbers. So you remember your divisibility rules. A whole number is divisible by 2 if and only if the ones place value digit of the whole number being tested is the digit 0, 2, 4, 6, or 8, which makes the whole number an even number. So because 32, 66, see, ends in 2, ends in 6, it means it's an even number. And all even numbers are going to be divisible by 2. Divisible means that when you do the long division, the remainder, see, divisible means when one divides a number by another, the result, the quotient, is a whole number with a remainder of 0 after performing the long division. So divisible means that after you do the long division, you get a remainder of 0. So this should be divisible by 2. So you need to reveal your divisor. Now, also maybe 4 might work, maybe, but we're safe with 2. So I'm going to just start with 2, and then I might be able to reduce it again. But let me just see what 32 divided by 2 gives me 16, and 66 divided by 2 gives me 33. So you can show your work like this. This is fine using a calculator. If you want to do the longhand multiplication, this is acceptable. Or you can show this, the longhand division. So that would look like this. You have 32, 32 goes inside the house. 32 divided by 2, 32 goes inside the house. So 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1. Bring down 2. And then 2 goes into 12 6 times. 6 times 2 is 12. So you see how we get 16? See that? And then 66 divided by 2. So I'm showing this because sometimes students are rusty with their long division. They need some practice. So again, 62 divided by 2. So 2 goes into 6 3 times. 2 times 3 is 6. 6 minus 6 is 0. Bring down the other 6. 2 goes into 6 3 times. 2 times 3 is 6. 6 minus 6 is 0. Okay. So this is your divisor. The common divisor is 2. And then you get 16 over 33. And then I don't think that can be reduced again, because 2 will go into 16, but 2 will not go into 33 evenly. You see, if I do 33 divided by 2, you see how I get a decimal. So 2 won't go into 33 even. And 3 will go into 33, but I don't think 3 will go into 16. If I do 16 divided by 3, I get a decimal. So 3 won't work. I think that's the lowest it can go. So usually when you try to reduce, by prime, well, by some prime numbers like 2, 3, 5. Not all of these are prime, but 2 is prime, 3 is prime. Here's a list of primes. Usually when you try to reduce also by a prime number. So these are real popular, the first 2 rows. If nothing in the first 2 rows work, probably it won't be able to be reduced anymore. But these are really popular to try. And of course, we were successful with 2. And so if I check my answer, I go back to the answer key. You can see here that that's 16 over 33. So we got that right. Okay. All right. And if I look at my template, if you're going to do your work on your own paper, you should always still read the template directions to know what your teacher's looking for. It kind of gives you hints, kind of gives you an idea of what kind of problems are going to be on the quiz just by reading the directions. But you can see, show work, not just the answer. Here, reveal the common divisor. So these are common things that are on these sheets to remind you. So if you're going to do the review online, then you should at least read the template, right, or watch the video to be included, right, in the understanding of the template directions. And if you're watching the YouTube videos, you should see your teacher following these steps in the videos. Okay, so next, change the improper fraction to a mixed number with the fraction part reduced to lowest terms. Show work. Okay, so what you want to use is you want to use long division to show your work. So you use long division to show work. Okay, and you have to know how to set it up. You have to set up the long division correctly. So when we took the first test, the first problem was comparing fractions. Was the first fraction less than, greater than, or equal to the second fraction? So there was quite a few number of students who wanted to change the fraction to a decimal, but when they set it up, they accidentally set it up wrong. So this is important. When you set these up, you want to make sure the numerator goes inside the house. So the numerator goes inside the house, the long division house. So this 50 goes inside. And if you're not sure what the numerator is the top number. Goes inside the house. So 50 divided by 6. So this 50 divided by 6 can also be written like this. 50 divided by 6, the line with the 2 dots. The fraction bar, 50 divided by 6 with the fraction bar, or the long house division. And then how many times does 6 go into 50 without going over? So you can use your multiplication chart, and 6 goes into 50 without going over, let's see, about, see, 48. So 6 times 8. So here, you can see here that 6 times 8 is 48. So we're going to use the 8 and we're going to use the 48. Okay, so 6 times 8 is 48. And 50 minus 48 is 2. Okay, all right. Now I'm not gonna put a decimal and a 0 and pull that up. A decimal, pull the decimal up, and then a 0. I'm not going to do that because we don't want to write a decimal. We want to change the improper fraction to a mixed number. So this is your R, which stands for remainder. So 6 times 8 is 48, plus 2 is 50. So we want to change this improper fraction. And improper fraction means that the numerator is larger. So change the improper fraction to a mixed number. So the numerator is larger than the denominator. That's what an improper fraction is, when the numerator is larger than the denominator, and you want to make it into a mixed number. So a mixed number has this look to it, right? This mixed number has this look to it. You have a whole number. This is, a whole number here. And then that's your numerator. and that's your denominator. Right, that's a mixed number. So whole number, numerator, denominator, okay. And an improper fraction is called that because see how this 50 is bigger than the 6? The numerator is a larger number. It's 50 is bigger than 6. That makes it improper. So now you want to make it look like this, a mixed number. So this gets recorded clockwise, like that. So you want to record clockwise, like the movement of the clock, not counterclockwise, against the movement of the clock, but clockwise. So you would start here with 8. And then the numerator is going to be this 2. And then see this denominator is going to be this 6, the divisor. So this is 8, 2, 6, 8, 2, 6, 8, 2, 6, okay? And then that can be reduced by 2. Well, the 2, 6 is even, and the 2, 6 can be reduced by 2 because 2 divided by 2, so don't forget your 8, the whole number, but 2 divided by 2 is 1, and 6 divided by 2 is 3. So 2 divided by 2 is 1, 6 divided by 2 is 3. So remember, every time in this course when you're reducing, you need to, like, that counts a point for revealing the common, remember, reveal the common divisor. So reveal the common divisor that you use to reduce that. And 2, 6 reduces to 1/3. And of course, you still have this whole number that's tracking. But that should be the result for that. Okay. So I go back and check that with 3. See how that's 8 and 1/3. So we did that correctly. Okay. All right. So you do have to know how to do long division. So if you need some tutoring, let me know if you need to do a little 30-minute session, tutoring session, and during office hours, or if you want to pop into Math Row, either in person in Math Row or virtually. With me, I have my Zoom virtual office hours. Math Row, they do both in person and also virtual. But if you need some help with long division, just pop in, get that done. If you need help with that, okay? All right, now, and so that's lowest terms. They said reduced to lowest terms. So this is reduced. This is not reduced to lowest terms, but the 8 and 2, 6 is not. But the 8 and 1/3 is reduced to lowest terms. All right. So your work would be you showing the long division, showing your common. This is show the common divisor. And then you write it as a mixed number. Okay. All right. And then let's see on the template. You can see on your template, reduce the fraction to 4. That was number 2. And then number 3. Change the following improper fraction to a mixed number. You said show your work. See, I even give you a hint. See, hint, long division. So you see your templates have little hints. They kind of jog your memory. Okay. Of course, you can use your study guide also open. It's like kind of like open book, open note, right? You can use this, and that also jogs your memory because I said here use long division to show your work. So that's a hint. So you can highlight that to help you with that. Okay. Little things like that to help you. Okay. So let's see. Change the following mixed number to an improper fraction, reduce if possible, and show your work. Okay, when you're changing, this is a mixed number and you want to make it improper. So the formula is that you want to take the denominator and you want to multiply it times the whole number. And you also want to add the numerator And then it's all over the denominator. Okay. So you take your denominator, which is 30, and then you multiply it times the whole number, which is 17. And then you're going to add the numerator, which is the top number, 7, to it. And then it's all over the denominator. The denominator is 30. And then usually, you know, my kind of rule of thumb is like, if you can find on your multiplication chart, then you don't have to show it by hand. It's kind of my idea. So if I can find 30 by 17 on my multiplication chart, although I can't find it on this one, but I can find it on that one, then I don't have to show it by hand. But 30 times 17, so times, this is the 30 times 1. So this is 1, for this multiplication chart, it was 1 right here. Because this one, see, the way it's got this bowl, this would be 12 times 1 here, 12 times 2 here, see, because they got it twice. But this one doesn't repeat. So this is 30 and 60. So this is 30 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I think it's going to be 510. Just use this ruler to help. That's 17, 510. So we can see over here. Yeah, 30 times 17. So 30 times 17 is 510. Plus the 7 over 30. And then of course, double check on your calculator too, right? You got your scientific calculator. So 30 times 17 is 510 plus 7 is going to be 517 all over 30. So don't forget the all over 30, okay? Because that's part of your formula here. See that? And then if I double check that work problem before, see, 517 over 30. See that? So it checks out. All right. So remember, there's an answer key. Remember, your course workbook has an answer key for the Math 105 Canvas course in the front of the workbook. In the back of the workbook is the 410. The front is the Math 105. So it's on page 52 is where you have the answer keys. And then the actual quizzes were back. The practice quizzes, right, were actually in the front somewhere. I think I was on I pulled out page 42. Right, so I pulled out page 42, but there is another practice quiz there that starts, let's see. Yes, there's other practice quiz on page 39, it's the other one. Okay, workbook. Right. Next. All right. Find the quotient, which is the quotient is the answer after doing long division. Reduce the simplest terms. If the value is undefined, type undefined, and then write using the long division. And then just, follow whatever directions the computer has, because the computer might have different directions on what to type here. But this is what this template says. This is what this quiz actually says here. Undefined. So they should have said write undefined here. But you have, and also we want you to rewrite your long division. So remember, the long division can be written with a fraction bar. It can also be written with the division symbol, the line with the 2 dots. So that's how you would write that. And then also it can be longhand. Remember, the numerator goes inside the house. So it's 0 divided by 29. So your teacher does want you to demo that when you show your work, that's part of showing your work for that. You need to know, let me know that you know how to set that up. 3 ways of writing long division. And then when you type in the calculator, well, also you can see here how many 29s go into 0. Okay. And there would be no groups that would work. And also if you do 0 divided by 29 in the calculator, see, that gives you also 0. So this is 0. And there's a cute way of remembering that. One spells no and one spells on. That's a cute way of remembering it. So here, this one spells on. The 0 is like the letter O. And 29 is a number. 29 is a number. So the number, that's where it gets the N from. And you see that kind of spells on. Like remember the Fonzie? Remember Happy Days? Fonzie, right on, right on. So you can do that division. And so the requirement for doing long division is that this is your divisor. So the answer you get is called your quotient. The answer you get after you do long division is called your quotient. And this is called your dividend. And this is called your divisor. And your divisor must be a counting number, not a whole number, because a whole number starts with 0. It's got to be a counting number. So in other words, 1, 2, 3, and so on and so on. If it's not a counting, if it's a decimal, then you have to tweak it. So if it had been, I'm just making this up. If it had been 0.4 as your divisor, and we're going into, I'm just making this up. 28, like that. This has to be a counting number. So to make this a counting number, you would have to move your decimal over and that becomes 4. But what you do the inside, you also do the outside. So here, where's your decimal? If you don't see it, this decimal will be hidden. It's right there. So then you have to move this over once. So what you do to the outside, you do to the inside. You have to move this over once to make 4 a counting number. But now this will grow into 280. Then now you can perform long division, right? 4 doesn't go into 2, but 4 goes into 28 about 7 times, because 7 times 4 is 28, remainder 0. Then you bring the 0 down. And then how many 4s go into 0? None, 0. So 4 times 0 is 0, and 0 minus 0 is 0. So when you perform long division, this divisor can't be a decimal. So this divisor can't remain a decimal in math. So you have to change it to a counting number. So you have to change to a counting number. We change it to 4, but because we moved it one time, we also have to move it one time on this inside here in the dividend. Now that grows to 280, and then you can perform a long division. Okay, so this is you can do this long division because 29 is a counting number. See, 1, 2, 3, ... These are ellipses, goes on forever. So you would hit 29. But this is going to pose a little problem for us on this one. 90 divided by 0. This can be written 90 divided by 0. This can also be written this way. 90 divided by 0, right? The numerator goes inside the house. So you need to remember that. You need to learn that. The numerator goes inside the house. You need, if you don't already know that, learn that. If you don't already know that, you need to learn that that the numerator goes inside the house. You just set it up correctly. You need to learn how to set up long division correctly. I can't stress that enough when you graduate from this class, okay? To set up long division correctly so the numerator goes inside the house. And you see there's a problem here because we just said the divisor must be a counting number. This is a whole number. 0 is a whole number. And so that's not allowed. 0 is a whole number. And so 0 is not allowed then in division. Yeah, because when you're doing division, you're breaking up into groups. You're saying how many groups, like how many groups of 29 can I create? How many groups of 29 items can we create? Can we sort? How many groups of 29 items can we create? Can we sort? So this was 0, none, because you didn't have enough. You didn't have any. But we would never spend time asking how many groups of 0. There's no point in saying how many groups of 0. There's nothing in there. So we don't spend our time doing that. So this one's the one that's undefined. If I do 90 divided by 0, see, your computer says dividing by 0 error. So that's what the computer says. Divide by 0 error. But the correct word for that would be that this is undefined. And the computer might have you type an abbreviation, just follow whatever directions the computer says, but we usually write undefined, which is, it's not possible here. So this is not a counting number, okay? But this is how you would set that up, okay? Hope that makes sense. Oh, and then the thing about the spelling, one spells on, one spells no. No, you can't do that. This one this is kind of cute, this idea, memory mnemonic. This one spells no. 90 is a number for a number. And then the number 0 is like your letter O. So you see that spells no, spells no. Cannot do that from division, okay? So this one spells right on, you can do that. This one spells no. Okay. All right, okay. So if I check my work, let's see, let's go back and check my work. 5 and 6. 6, here we go. So 5 is 0, 6 was undefined. 5 was 0, 6 was undefined, okay? And then you want to be able to set up your long division three ways. So write your long division, okay? On your paper. All right, that's for the full credit. All right. And so this was undefined. All right, now find the LCM. LCM stands for least common multiple. That's what LCM stands for, least common multiple. Find the LCM of the given set of counting numbers. So the first one, we have 21, 14, and 9. Okay, so show your work. So you want to show your work and you want to use a list of multiples. Okay, so, and you always begin, you use a list of multiples and you begin with the largest number in your group. So in our group, we have 21, 14, and 9. So it's already in order. So we'll start here with 21. Okay. So we're going to do 21 times 1 is 21. 21 times 2 is 42. 21 times 3, 63. 21 times 4 is 84. And you can certainly double check on your multiplication chart because that's on here. You can see here 21. There's 21 times 1, 21 times 2, 21 times 3, 21 times 4, 21 times 5 is 105. Let me do one more. 21 times 6. What's 21 times 6? 1, 2, 3, 4, 5, 6, 126. Okay. And then maybe we can stop there. I'm not sure what the answer is. Maybe we can stop there. We'll just see, where we might have to make a longer list, but the way we'll know is we want to look for a common, the common multiple, and the least, the first time that it appears common. And sometimes people will overlook it and find a common multiple instead of the least common, but you want the least common. So 14 would be next. So 14 times 1 is 14. 14 times 2 is 28. So we're looking kind of for a match. 14 times 3 is 42. So maybe that's the match. See, there's 42 there and 42 there. So maybe that's the match. So we can stop there and just see. Let's work with 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27, right? So we look at 9 times 1, 9 times 2, 9 times 3. 9 times 4 is 36. So 9 times 5 is 45. So you see, I didn't get a 42 out of that. So that means it's not 42. So that means we have to keep going. Okay, so let's see. 9 times 6, so is 54. And you see, I don't see a 54 over here, so I got to keep going. 9 times 7, let's go here, 9 times 7, 63. Okay, well, you see, I do have a 63 over here. So maybe it's 63. Let's see, because it has to be common to all three of them, of these numbers. So let's go back to 14. What's 14 times 4? So times 1, times 2, times 3, times 4 is 56. 14 times, what's 14 times 5? So 14 times 1, 2, 3, 4, 5 is 70. Okay, so you see that's not a match then. We got to keep going. 14 times 6. Let's go back to 14 times 6 is 84. Maybe that's the match. Maybe that's the match because see, there's an 84 here. So let's try the 9. 9 times 8. So go back to 9. So 1, 2, 3, 4, 5, 6, 7, 8. 9 times 8 is 72. 9 times 9 is 81. So it doesn't look like that's going to work because 9 times 10 is 90. So you see that's not going to work then. How about 9 times 11 is 99. 9 times 12. 2, 3, 6, 7, 12 is 108. So we've got to go past that because see where this is 105. How about 9 times 13? So 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is 117. How about 9 times 14? So we're at 9. So we were at 17. So 126. Well, that might be hopeful because see that's a 126 for the 21. Now let's see if we can find a 126 for the 14. So 14 times 7. 1, 2, 3, 5, 6, 7 is 98. What about 14 times 8? 1, 2, 3, 4, 5, 6, 7, 8. That's 112. Looking good. I think I saw that. 14 times 9. 14 times 9. 14 times 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 126. That looks like that's the match then, because you see, now we see that. And so, and oftentimes what you want to do is just double check, because sometimes people, if you have a long list and you don't find a match, then you want to double check, because sometimes you look at the wrong number on the chart or you type in the wrong number. So what you should do is go back, like for 21, and just double check here. So like, I'm going to double check with my fingers, see. So 21, 42, 63, 84, 105. You should do that. And then for the 14, we have 14, 28, 42, 56, 70, 84, 98, 112, 120. See that? And then for the 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99, 108, 117, 126. You should double check that. Because sometimes if your list is really long, then maybe we made a mistake, either in typing the numbers in, because you could also type, 21 times 2, oops, 22 times 2, and write it down. 22 times 3, and then write it down. 22 times 4, and then write that down, right? Oh, let's see, I made a mistake, because the number's not even 22. Sorry, it's 21, but you get the idea. 21 times 2, 20 times 3 times 4. So you can also, create a list that way as well. Just be careful what you're typing. All right, but we did find the match, right? It was 126, right? Okay, and then if I double check that answer, number 7, it's right here. See that right there, 126. All right. Okay, now there's another way. Let me show you another way to show your work that you might be interested in. I'm going to do that on a separate sheet of paper, in case you're interested in the other method. So the other method would be, if I do a factor tree, 21 is 3 times 7, and 14 is 2 times 7, and 9 is 3 times 3. And these we can stop here, because this is called, we have to compute, we have to do the prime factorizations. The prime factorizations. So when we do this prime factorization, what we're doing is we're making a factor tree. We're making a factor tree. Okay, these are factor trees. And these are prime. So we can stop here, because these are all prime numbers. And if you remember your list of prime numbers, see, 3s and 7s and 2s, see, 3s, 7s and 2s. These are prime numbers, so we don't make any more, we don't break the tree down further because these are prime. But what you do with this other method is you do the prime factorizations, you figure the prime factorizations, you make factor trees, and then when you set them up and you write them, 3 times 7, kind of organize it, I guess, like kind of in order, like 2 times 7, so like the 7s underneath the 7s, 9, 3 squared, so the 3 underneath the column of 3s, but there's 2 of them, so an exponent, that's an exponent, that's base and exponent, it's your base and your exponent. And what you want to do is you're trying to find the LCM, right, which is the least common multiple, right, which is synonymous with the LCD. Just so you know, the least common multiple is going to be the same value as the least common denominator, so you can use them interchangeably. LCM, LCD, least common multiple, least common denominator. And with this method, you have to make prime factorizations, and then you have to use each different prime factor, and when factors repeat, you want to use the factor with the largest exponent, because opposite of least is greatest. Opposite of least is greatest. So you want to use one with the largest, with the greatest exponent. And so what's happening is the 3s are competing against each other. See, so you have different factors. Would be, you definitely want to use a 2, definitely want to use a 3, definitely want to use a 7. Okay, you got to use different prime factors. But then when they're competing, like these 3s are competing, you want to choose the one that's got the greatest, the largest exponent. So this 2 is bigger than this imaginary 1, so you want to use that. So you want to go with 3 squared. Now the 7s are tied because this has a little 1, imaginary 1. All these have an imaginary 1 that we don't bother writing, but they have an imaginary 1. So those are tied. So you just want to use one of them. Okay, when they're tied like that. But when this has a 1 exponent, this has a 2, you want to use the one with the biggest exponent. So use 2. But if we and you want to use each different prime factor, and when factors repeat, you want to use the factor with the largest, greatest exponent, and then you want to multiply. And after we multiply that, we should get the same result that we got over here. When we're done, we should get the same result that we got over here. We should get 126 when we're done. So over here we have LCD, which is equal to LCM, which is 126. We should get that same result, but using this is using a list of multiples. This is a list of multiples. This is called using prime factorizations, making a factor tree, and then doing some multiplication using the different prime factors, and then the ones when they repeat, then you want to use the ones with the greatest factors, the greatest exponent. So this would be 2 times 3 squared means 3 times 3. That's what that means. 3 squared means 3 times 3, not 6. So 3 squared does not mean 3 times 2. Okay, 3 squared does not mean 3 times 2. Instead, 3 squared means it's equal to 3 times 3. So this is a common error that I see when students are learning. So this is not true. 3 squared does not equal 3 times 2. It doesn't equal 6. 3 squared means 3 times 3. So these are bases. And this is an exponent. And that tells you how many times to multiply it over and over repetitively with each other, right? Twice, okay? So then this gives you 2 times 3 is 6. And then here 3 times 7 is 21, because we take them 2 at a time. And then when I do 21 times 6, 6 times 1 is 6, 6 times 2 is 12. That gives me 26. So I have 2 times 3 times 3 times 7. 2 times 3 times 3 times 7, which is 126. Okay. I guess another way to write that, to type that, would be 2 times 3, and then I can hit this squared. See this squared there? Squared, see that? And then times 7. I guess that would be another way to write that down. Another way to type that would be 2 times 3, and then the hat. See this hat? That hat raises it to the second power. See what that hat did? That little hat raised that to the second power. And then let's see, times. Oh no, then I have to push it back down. See how that's floating? I don't want that floating. So let me go back over here, hit this button, and let me delete that. And then push this down. See that? Push that down. And then do times. Oh, nope. Go back and delete. How do we push that down? There ought to be a way to push that back down. I thought it was this. Yeah, it was that. I don't know why it didn't work, but I guess I didn't do it there. But yeah, that did. I think I pushed this part right here. This right here. This part is what I pushed here to push that down. And then times 7. Okay, so those are all the different ways. I use the exponent of 2, I use the hat, and then just the plain times. All those work. Okay. All right. Okay, so we got 126. Okay, that's another way. That's another method in case you like that method. Okay. All right. And then number 8, we're working with 7 and 5. Okay, so 7. Yeah. Okay. All right. And so now over here, I go with 7. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 20. 7 times 5 is 35. And we should just double check. This one we can double check on the multiples of 7 here. So 7 times 1 is 7. 7 times 2 is 14. Times 3 is 21. Times 4 is 28. Times 5 is 35. Okay. All right. And we could keep going, but I think we're going to find a match because I think 35 is the answer. So now I do the multiples. This is a list of multiples for 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 20. Remember, you're looking for a match the first time they match. And 5 times 6, 30. 5 times 7 is 35. And see, that's the first time that these will match. See that? And so the LCD is equal to the LCM, which would be 35 here. And if I check that on the workbook here, if I check that on my workbook, you can see here, see that, let's see down here. See that, 35. Okay. All right. Okay, so now, the other thing I was going to suggest too, you just put LCD equals LCM equals 35. Another way too of showing your work, if you're using list of multiples, is to write out the multiples the way they do here. So like, or like the way they do on this sheet here, you could do that. So like, you know, for example, you have 7, maybe you start with the largest number, 7 and 5. So another way to work is to show your work like this. So you do like 7 times 1 in your head, 7, you write 7. 7 times 2, you do that in your head, 14. 7 times 3, you calculate that in your head and you write down 21. 7 times 4 in your head, 20, write down. 7 times 5, your head, and then 35, you write down. So you can do that and show your work this way, or you can show your work this way. So this is another way, because you're making a list of multiples. That will work too. So 5 times 1 is 5. You do in your head 5 times 2, which is 10. In your head 5 times 3, and you write down 15. In your head 5 times 4 is 20, and you write down 20. In your head you do 5 times 5, which is 25. 5 times 6 is 30. And then so 5, 10, 15, 20, 25, 30, 35, until you find your common match. Okay, so that's the LCD, the LCM is 35. Okay. And then if on this one, if you do the other method, it's just not much to show it on the other method, because the paper. If I do, that was number 8. So another method, there's not much to this other method for the LCM though, because other method to find LCM. For problem number 8. It's because there's not much work to show on that method, because when you try to do a tree, you know how we're trying to do a factor, make a factor tree for these numbers 21, 14, 9. These could be broken down, but the thing is that when we're working with 7 and 5, they're already prime. So you know, for 21, I was breaking it down to prime factorization, 3 times 7, but 7 and 5, they're already prime already, so you don't have like a factor tree that you can make. So then when you get ready to on your work, LCD equals LCM, LCD equals LCM, or LCM equals LCD, either way. When you try to use all the different prime factors, well, your prime factors are the 5 and the 7. And then none of them are repeating. None of them like have greater exponents. Like over here, these 3s were competing. So it's just, these are just 7 and 5, which gets you to 35. So that method's, you know, there's not much to show on something like that. It's so short. All right. So this kind of might make more sense in that case. All right. All right. And then the last problem, list the first 6 multiples of a given number in order. Show work, separate your answer with commas. Okay. So again, you want to here we want to show you to multiply. So you know, 40 times 1 is 40. 40 times 2. So this I'm going to show because this is not a multiplication chart. So on these, I didn't show the longhand multiplication because remember it was within the 30 by 30. But see, 40 goes off the chart. See, this is 30 by 30. And 40 goes off that chart. So that's why your teacher's doing, if we use that rule of thumb, anything that goes off the multiplication chart, then we show by hand. So that's why I'm showing this by hand. So 40 times 2, 0 times 2 is 0, 4 times 2 is 8, 40 times 3, 0 times 3 is 0, 4 times 3 is 12, 40 times 4, 0 times 4 is 0, 4 times 4 is 16, 40 times 5, 0 times 5 is 0, 5 times 4 is 20. And then 40 times 6. So 0 times 6 is 0, 6 times 4 is 24. And then of course you could double check on the CAD just to make sure you didn't make any errors. But I'm doing it longhand, and it says the first 6. So 1, 2, 3, 4, 5, 6. Okay, and then this would be your work. This is fine. And then the computer, when you write your answer in the computer, they'll probably remind you to separate your answers with a comma. So then in the computer, you'll be putting 40, comma. So it's a comma, not a semicolon. 40, comma, 80, comma, 120, comma, 60, comma, 200, comma. You would type that in the computer using commas for that. And then we double check our work for that. Let's make sure. We're at number 9. So you can see 40, 80, 120, 160, 200, 240. Okay, so that checks out. And so if I go back and reference this template, showing your work, you see it's separated by lines here to show your work. But see that now you're familiar with the template, right? Because you saw your teacher writing that. It kind of tells you how many questions of each type. So this helps you to look at that. So here's the 9. And you just don't know how many multiples. It might change. This one we had said find the first 6. But that could change. It might be the first 8 or first 9 or the first 4. You don't know, and you don't know what the number is either. Okay. All right. So study for your quiz. Watching this video will help you. Will help you study for your quiz. And you can use these as study guides while you complete that, and you have the available papers and that's that you need, like your multiplication chart. That can help you, and your list of prime numbers, your divisibility rules, and your list of prime numbers, which was in the back of one of these sheets there. Okay, but those are things that you can use when you're taking this Canvas Respondus quiz. Okay, so in order to take that, you have to have the certified work from 2.1 and 2.5 done. Okay, and then just make sure you're making a PDF and uploading your work in the computer. That way you won't get 10 points taken off your certified score for that. I have to do that manually if that happens. And then you have 50 minutes to turn in your work. And then just make sure that when you turn in your work, you're turning in all your pages of work. And so I teach statistics online as well as the elementary algebra plus, and that's seems to be a reoccurring issue with students. They need to learn that it's the responsibility to double check that they turn in all their pages of work. So you just check from your Canvas course, you're already taking a Canvas quiz or a Canvas test, right? So you're already in Canvas. So just go to your Canvas course and go to modules and click on the link, the modules link, and go to that name of that assignment. And then you just double check and look at what did you actually submit. So don't rely on your Canvas app. Because that's not a good source to rely. You need to actually double check that. Because I think if you do multiple pages, you would need to see multiple downloads downloaded. Because if you just oftentimes what happens is with multiple pages, you could easily maybe just upload the last page or the first page, which overrides like previous pages, unless you do the add feature. And so you want to practice that ahead of time. You have an hour to troubleshoot. So I gave you 60 minutes, an hour to troubleshoot that issue, but really it should just take you 5 minutes to turn in your work. I give you 15, and then the hour is with a 10-point penalty. if it's beyond 50 minutes to within the hour to troubleshoot, but that is the student's responsibility. So you don't, teacher doesn't go back and grade and review after the session has closed. I grade just what gets submitted during that scheduled time, that it's open and available. And then after you submit your test, you have that time frame of 50 minutes to an hour to turn in work. So that is the student's responsibility. So make sure you learn that. And that should have been learned like during orientation. And you had orientation, you know, you look at the instructions on that. You were asked to submit like at least 2 pages of work for the practice, right? So just work on fulfilling that, okay? And good luck with your study. If you need tutoring, remember also math rows available for you. So in your module, you have a math row link that you can join, and then an operator will come on board and then greet you, maybe ask you for your banner ID, ask you what subject you need tutoring for, then they'll put you in a break room with somebody who's available to help you with your homework questions, your practice, your certified problems. And so they'll help you with that tutoring, okay? All right, good luck to you. Take care.